Lesson 3.4, Dividing Polynomials. In this lesson, we'll look at two different methods used for division. We'll also apply the remainder and factor theorem. Long division is how we'll start. And long division just takes a polynomial divided by something else. The original polynomial that you start with is called a dividend. That's just whatever big polynomial you have initially. You'll divide by a smaller polynomial, and that's going to be called the divisor. The answer you get in division is called a quotient. You may or may not have a remainder. Let's start with just numbers. It says divide using long division. 1,569 divided by 13. Could you plug this into your calculator? Absolutely. However, we're going to follow the long division model to apply it with polynomials. The first number written is always the dividend, so that's the number that goes in the dividing bar. What you divide by is the divisor, and that goes on the outside of the dividing bar. So 13 would go on the outside, and 1,569 goes on the inside. When you do long division, you take the number of digits in the divisor and you match it up with the first amount of that digits in the dividend. I don't know if that made sense. So 13 has 2 digits, therefore we look at the first 2 digits of the dividend. 13 would go into 15 one time evenly. That means I would take 1 times 13 and write that below. And then we subtract to see what's left over. 15 minus 13 is 2. Now we drop down the next number so that we have 2 digits again. 13 goes into 26 2 times evenly. So 2 times 13 is 26. And when you subtract, there's nothing left over. When we drop down that last number, 9, 13 doesn't go into 9 evenly. Because of that, we have to write a 0 as a placeholder. 13 times 0 is just 0, and that means we have 9 left over. 9 is the remainder. If you can get that to fit in there. 9 is the remainder. So we would write out our quotient as 120 with a remainder of 9 over 13. So if you took 120 times 13 and added 9, you would get 1,569. Let's see if we can apply this with polynomials. It says x cubed plus 5x squared plus 6x plus 9 divided by x plus 3. The original polynomial is our dividend. And what we're dividing by is our divisor. The divisor goes on the outside of the dividing bar. Make sure to give yourself some space because we're going to write up above. And the dividend goes on the inside. X cubed plus 5x squared plus 6x plus 9. All right, I'm going to put a 1 as my placeholder, or as my coefficient for my lead term. So now what we do, this is a little bit trickier. Now we're going to take the first term on the outside and the first term on the inside. To figure out how many times x goes into x cubed, what would we have to multiply x by to equal x cubed? We'd have to multiply it by x squared, and then we'd add their exponents together. So x squared is actually in the next term. I'm going to write x squared up above. Whatever you write up above, you multiply to both terms, and then you match it up where their column is located. X squared times x would be x cubed, so that just lines up underneath that first term. But if we take x squared times positive 3, that would be 3x squared. And that lines up perfectly in that next column. Now when you draw your line and you subtract, you have to remember, like we subtracted in that first problem, you have to remember to subtract both terms, not just the first term. And your goal is for that first term to always cancel out. X cubed minus x cubed cancels out. And now we just look at what's left over. 5x squared minus 3x squared, we'd have 2x squared left over. Just like that problem on the left, we drop down the next term and we repeat the whole process again. So now we have 2x squared plus 6x. Take that first term on the outside. What could we multiply it by to equal the first term in that row? X times what would equal 2x squared? Well, we'd have to multiply it by 2 to get the coefficient, and we would multiply x times another x to get x squared. What this means is we multiply it by positive 2x. Multiply that to x, and we get 2x squared. If we multiply it to 3, we get positive 6x. Now when we subtract, notice once again, the 2x, the first term should cancel out. But in that second term, it also cancels out, and we have 0 left over. Now if we drop down our next term, trying to match up x with 0, nothing works there, so technically we would add 0, which doesn't seem to make a whole lot of sense, but we'd add 0 in there, and then our remainder, again, is 9. To write this quotient then, we would have x squared plus 2x, and then with that plus 0, you wouldn't have to technically write plus 0 because 0 really is just a placeholder, and our remainder would be, since it's positive 9, would be plus 9, again over our divisor of x plus 3. That is the quotient in long division. If a term is missing in the original dividend, we use zeros as the coefficient. And what I mean by missing terms is once you know your lead term, all the terms with degrees smaller than that, or exponents smaller than that. All terms in the dividend must be in the original division problem. Here's what I mean. Over on the right-hand side, example B, we have 8x cubed plus 27 divided by 2x plus 3. So whatever's written first is always our dividend, and whatever's written second is the divisor, whatever it's being divided by. The divisor goes on the outside, and the dividend always goes on the inside. But notice we go from 8x cubed, which is a cubic term, right to the constant. We're missing an x squared term or a quadratic term, and we're missing a plain x term or our linear term. If we write out our first term, 8x cubed, we still need to represent the location of the quadratic term, so it gets 0 as a placeholder term, or as a placeholder coefficient. We're also missing our linear term, so another 0, and then we can write in our constant. So the zeros don't really change the value of the dividend, but they'll make our quotient possible. All right, we're going to apply that same process that we did up above. Underline the first term on the outside and the first term on the inside. We need to make those two match up. How can we multiply 2x by something to equal 8x to the third? Well, 2 times 4 would equal 8, and if we multiply x by x squared, we'd get x cubed. Notice that'll put us in our second column again, 4x squared. If you multiply 4x squared by 2x, that would give us 8x cubed. And if you multiply 4x squared times positive 3, that gives us 12x squared. Draw your line, and in this row we subtract. Make sure you subtract both terms, so we're changing both their signs. Notice 8x cubed cancels out. But when we have 0x squared minus 12x squared, that would give us negative 12x squared left over. And we drop down the next term. And we repeat the process all over again. That term on the outside, 2x times negative 12x, or times what, equals negative 12x squared. Now to get 2 times negative 12, we'd have to multiply by negative 6. And to get x to become x squared, we would just multiply it by another x. This means we have to multiply by negative 6x. If we distribute that to the first term, we'd get our negative 12x squared. But if we multiply negative 6x times positive 3, we would get negative 18x. Oops, and I'm not writing 18, am I? There we go. Draw your line. And now watch what happens. You guys, if we're going to subtract this row, subtracting negative 12 actually means it's going to change to addition. Subtracting negative 18 would change that to addition as well. And now notice the negative 12x squared in red and the positive 12x squared in purple are opposites, so they cancel out. 0x plus 18x would give us 18x left over. Drop down the last term. All right, one more round, everybody. Let's see if we can make this happen. What could we multiply 2x by to equal 18x? Well, 2 goes into 18 9 times, so if we multiply it by 9, we'd get 18. And x already matches with x, so now we don't have to multiply by a variable. We're just going to multiply by 9. Multiply, all the way over to that first term. 9 times 2x is 18x. And get this, you guys, 9 times 3 is 27. When we subtract this row, we'll subtract the 18 and the 27. Both the 18x and the 27 cancel, which means our leftover amount is 0. So there's no remainder. The quotient then is just 4x squared minus 6x plus 9. And that's your answer using long division. At this point, if you're thinking to yourself, wow, these problems are going to take forever, there's an alternative method to division that doesn't have quite as much work. It's called synthetic division. And synthetic division works when your coefficient with x is just 1. So if you have x minus a as your divisor, you just use x equals a in this kind of division. The unique thing about synthetic division is you're only using coefficients. You're not actually going to use the variable. And like long division, all terms must be present. Here's what synthetic division looks like. I attribute it to playing hockey. It has nothing to do with hockey, but I use hockey terms, so it's kind of fun. We have 5x cubed plus 18x squared plus 7x minus 6. So this is the dividend. We have x cubed, x squared, x, and a constant. All terms are present. Divided by x plus 3, that's your divisor. Notice the coefficient in front of x is 1. So if x plus 3 is the divisor, then we plug in the opposite sign in long division, in synthetic division. So you always use the opposite sign. It's where the x-intercept would be on this if we were to graph this. So here's what I mean by it's kind of like playing hockey. We have a penalty box and a blue line. And that's really the only hockey terms, but it's kind of fun. The penalty box goes over on the left, and that's where you put the x value you're plugging in. So I'm going to put the negative 3 in the penalty box. To the right of the penalty box, I put all of my coefficients in order. We have 5, positive 18, positive 7, and negative 6. So I'm just going to write 5, 18, 7, and then make sure to include the negative with the 6. Give yourself a row of work and then draw a line. I'm drawing a blue line because it's my hockey reference, but any line will do. To do synthetic division, your first step is to drop that first number right below the blue line. Once a number drops below the blue line, you multiply it with the penalty box. So 5 times negative 3 is negative 15. Once you know that answer, it goes up above the blue line, negative 15. So what we did was we multiplied with the penalty box and then moved it to the next column. Anything that's above the blue line, you add together. 18 plus negative 15 would be 3, and that goes below the blue line. And you repeat the process. 3 times negative 3 would be negative 9, and that goes in the next column. So it's just kind of up and over each time. 7 plus negative 9, or 7 minus 9, would be negative 2, and that goes below the blue line. Last but not least, negative 2 times negative 3 in the penalty box is positive 6. Negative 6 plus 6 is 0. So you've done the process of synthetic division. It's that simple. But now, what are these numbers and how do they help us get our quotient, get our final answer? We use the numbers in this bottom row for our quotient. The quotient always has variables in it, but we start with one less than the lead term. So the lead term was 5x, sorry, hang on. I'm not going to write that. The lead term was 5x cubed. So we're going to reduce that in our quotient by 1. And we use the numbers that are in the bottom of our synthetic division problem. So we're going to start off with that 5, but instead of x cubed, it's going to be x squared. We do one less. The 3 is next, and it's positive, so it's going to be plus 3, and reduce your exponent, so plus 3x. The 2 is negative, so minus 2. And notice there's no variable with it, so that's our constant. Since 0 was the last number, that means there's no remainder. So x plus 3 goes into 5x cubed plus 18x squared plus 7x minus 6 with a quotient of 5x squared plus 3x minus 2. So this is the part 1 video. Take a break, come back, and watch part 2 when you're ready.